I want to take a look at a couple of these problems that I assigned yesterday out of the book. And these are weird because they talk about resonances. Okay. Now remember, there's a couple things you should know. There's air columns with resonance, and there's strings with resonance, and essentially they resonate at half wavelength intervals. It's just a matter of where they start. Okay, you can have an open air column, which is open on one end, and you can have a closed air column, which is actually an open air column is open on both ends, and a closed air column is closed on one end. And with an open air column, you have two nodes, right? A node on each end. Node, node. Okay, and what that means is you can have half wavelengths, but the longest wavelength you can have, the fundamental wavelength, if you will, of this thing is lambda 1, and it is equal to twice the length of the tube. In a closed thing, you have antinode node, okay? Because one end is going to vibrate back and forth between high and low pressure, the other one's always going to be medium pressure, okay? And again, you're going to get half wavelengths in there. Every half you're going to go from a node to a node to a node. But the difference is you don't start with a node, okay? You start with an antinode. So your first wave that fits is actually a quarter wave, and your next wave that fits is a 3/4 wave, because this is a quarter, and then every loop after that is a half of a wave. Okay, so we still have half wavelengths, but now our fundamental frequency is not twice the length, it's 4 times the length. Okay, now we're still going to have steps of a half wavelength. Okay, it's just that we're starting in different places. Okay, and so this one, our next one, lambda 2, is the length of the tube. Okay, well, this one we skip lambda 2 altogether because it can't do a half a wavelength, but it can do 3/4 of a wavelength, and so this becomes 4/3 times the length of the tube. Okay, and that was kind of some stuff from yesterday. Now the practice problems, they say what's a 440 hertz tuning fork is held above a closed pipe. Okay, so frequency 440, and it says it's held above a closed pipe, which means that we're going to have resonance going on in there. But do we have to care that it's closed? Well, I don't know that we do. Okay, it says the temperature is 20 degrees Celsius, and by telling us the temperature, that's telling us that the speed of sound is 343 meters per second. Okay, so we take V equals wavelength times frequency, and so 343 equals lambda times 440, and if we divide this out, 343 divided by 440 is about 0.79. Let me double check my math on that. 343 divided by 440, yeah, 0.779. Okay, so the wavelength of this wave is 0.779 meters, and it wants us to find the distance between the spacings, or the distance between the resonances. Okay, well, if we do that, okay, we got to stop and think, and we're going to be like, well, it's a closed tube, which means, okay, the first wave that'll fit is going to be 4 times the length of the tube. But then what's the next wave that's going to fit? Well, it's going to be half a wavelength different, because everything in here changes. So that's what they're asking when they're asking for the distance between the resonances. So if I divide this by 2 over 2, okay, then I get 0.389 meters, and so that means every time that the tube changes, or you move the fork or whatever, by about 0.4 meters, you're going to get another resonating column. Okay, the rest of these problems are sort of similar to that, so make sure you can work those out. Let me know if you have any troubles. Okay, the other thing I want to take a look at today is this idea of frequency and overtones. Okay, now the longest wave that'll fit in a tube is called the fundamental frequency, or the fundamental wavelength. Okay, and everything above that that'll fit is an overtone. Okay, so the fundamental F1 is the first harmonic. Okay, and For a closed pipe or an open pipe, you're going to get resonating frequencies. Okay. For a closed pipe, since these happen, every half wavelength, but starting on a quarter wavelength, then the frequency, the first frequency happens when the wavelength is equal to 4L, and since velocity equals wavelength times frequency, basically what I have is V divided by 4L is the first frequency, the first harmonic. Okay, and from there the length is going to change accordingly. Okay, and so a closed pipe will also resonate on the odds, right? 4/3, 4/5, 4/7, and so basically we can say F2, or sorry, not F2, F3 for a closed pipe is equal to 3 times F1, and F5 for a closed pipe is equal to 5 times F1. Okay, in open pipe is going to be a little bit different because it doesn't start at a quarter, it starts at a half and it goes every half. Okay, so F1 is V divided by twice the length, and then there is an F2, it can go every single one of them. Okay, and it's just 2 times F1. F3 would be 3 times F1. Okay, so you can see how this kind of works same way. This is the first harmonic, the first overtone, if you will. I guess it's the first harmonic. These are overtones. Okay, and so the first harmonic is the fundamental frequency. Okay, and there might be a couple questions on that as well.